Hey everyone, welcome back to 197 Concepts. So, in this video, we are going to discuss again the working of ultrasonic sensor and a different application. So, in the last video, we have discussed the working of an ultrasonic sensor, and based on that, how to calculate the distance between your system and the object that is in front of the ultrasonic sensor. Okay, so here what we are going to do is we are going to talk about an application which is nothing but the smart railway gate system. Okay, so smart railway gate system, as the name itself defines, it's the gates will close by itself when the train is about to come at the crossing. So that's a brief description. When you go deep into it, first of all, you will be very familiar with the railway crossings that we have in our country, and for every railway crossing, definitely eh, where there is not a possibility to construct a bridge, there is definitely a manual crossing. You might be familiar with the railway crossing. You will be having a track on the road, railway track on the road, and the two gates will be there, uh, one on each side, in order to stop the traffic, the crossing of these railway tracks by the traffic. So for operating these gates, definitely there should be a labor, or you can say that there should be a man in order to monitor the railway path. Okay, so if a train is about to come at the gate, and if that railway tracks are falling in between the road or across the road, if the railway tracks are going across the road, then they definitely we have to put the gates, and for that gate, definitely a man has to be there. So for that, what we are doing is we are designing a system in such a way that if the train is at some particular distance from the gate, that is the railway crossing, the gates will automatically close themselves, and when the train leaves, the system will automatically recognize that this train has crossed the railway crossing, and it will open the gates. Okay, so for that, let us try to understand the operation. Okay, our idea. So for that, yeah, it's a blank paper. What I'm thinking is, if I'm talking from the top view, okay, so you can say it as a bird's eye view. That will be much clear. Okay, so if you are having a road in this way, and you have railway tracks like these, so I'm going to draw it much thinner. So this is the road. Okay, so let's change the color, not white, let's go with yellow. This is the road, this is the road. Okay, so this is track, railway track. Okay, and the main part, what we want is the gates. So for the gates, if there is a red color, it would be much better. So let's check for the red color. Where is the red color palette? Okay, let's go with the pink one. It is much distinguishable here. So this is the gate. Okay, and here there is another gate. Okay, my drawing is not good. So these gates will automatically close and automatically open without the need of human supervision. Okay, so like this, if you see the front view, this is one gate, gate one. Okay, this will open in this way, and you have another gate that is right behind this, somewhere there. This will be opening in this direction. Okay, so we need two motors that is able to rotate at an angle of minus 90 degrees and at an angle of 90 degrees. Okay, so that's the basic idea. And the basic idea for this is, let us assume that you are having a railway crossing at this part. This is RC, that is railway crossing. So here we have all the gates, all the railway crossing, all the traffic and all. The whole setup will be done here, the motors and all. But for recognizing or for monitoring the arrival of the train, so that at a certain distance, what you are going to do is you are going to keep a sensor here. Okay, so you are going to keep a sensor here. This sensor will detect the with will detect the arrival of the train, and it will send a signal to this modules. It will send a signal to this module that I have detected the train and it is coming in your direction. So this here what we have is we will be having a module here, or we can say that a controller. We will be having a controller that will detect this signal, sent by this sensor, and it will close the doors, close the gates. So initially if they were at minus 90 and 90 degrees, now they are going to be at 90, and this one will be at plus 90. Okay, not plus 90, you can say that this is 180 degrees, whereas this is 0 degrees. This is the initial position of the gate, this is the 180 degrees rotation. Okay, you can say it that way. And when the train crosses this path, the sensor will tell that there is no obstacle or there is no train in front of me. It will send another signal to the module here, which will interpret this signal and tells that the train has crossed this area or this area, and the gates are free to open, so the traffic can flow. That's a basic idea. Now the signal, that's not our problem, so it could be any signal, sound signal or anything else, but we are using electrical pulses. Okay, here we are using electrical pulses. Mostly it's a digital kind of signal, digital signal. Okay, so if it is a digital signal, definitely we have logic 0 and logic 1. Okay, now the best controller or the budget controller that is easily available and can interpret the digital signal is nothing but our Arduino board. Okay, Arduino board. So for the controller part, I'm using the Arduino board, and for the sensor, we are using ultrasonic sensor. Ultrasonic sensor. This is the sensor. Okay. So our basic setup is you will be having an ultrasonic sensor and you have an Arduino board, and for the rotation of the gates you will be using two servo motors in order to open and close the gates. You will be using two servo motors, right? So that's the basic idea. If you go for the setup, I will just give you a rough diagram here. Definitely, we will discuss the pictorial representation also. So the basic setup is you have Arduino board AB, and to this you have connected an ultrasonic sensor, that is US, and in order to generate the output you have motor 1 and motor 2. This is the basic setup. Now the ultrasonic sensor, okay, uh, you can tell that at this gates you definitely will be having. So if you assume that this there is a gate attached to this one and there is a gate attached to this one, and here is the ultrasonic sensor. Now okay, if I am able to draw this properly, you will be able to understand. What I'm going to do is, this is the railway track, this is the railway track, track. Okay, and I will change the color. I will go for the black. What I am doing is I am keeping a gate here, G1, and a gate here, called as the G2. In order to operate these two, what I'm going to do is I'm going to attach a servo motor SM1, and this is SM2. For controlling these two, I need definitely a microcontroller, which is nothing but the Arduino board. This Arduino board is attached to this servo motor and this servo motor too. Okay. Now, to sense the arrival of the train, what I'm going to do is I need an ultrasonic sensor. So, yeah, that will be fine. I'm not going to keep the ultrasonic near the gateways. I'm going to place it somewhere far within the range, of course, within the range, but somewhere far with the gates, because the train will be traveling with some speed, and if it is too close to the gates, the ultrasonic sensor will sense the signal quickly and it will send to the Arduino board. But the Arduino board will send some signals to these servo motors, and these motors will take some time to react. Okay, during that time, if someone crosses these gates, it will be very risky. For that purpose, what I'm going to do is I'm going to keep the ultrasonic sensor a little bit far away from the gates. It will be within the range of the Arduino board. If it is if it is more than if it is outside of that range, then you can keep a repeater also, no problem. By using ultrasonic, that's some other different programming, that's some other case. For our basic project, what for our prototype or basic project, what we are going to do is we are just going to keep it at a certain distance, minimum distance. You might ask me what will happen here. You see, the train doesn't come always in this direction, it may come in this direction also. Yeah, no problem. You keep an ultrasonic sensor here also, okay, and connect it with the Arduino board. This is the basic set. But for the simplicity, we are not considering this one. We are just considering only one ultrasonic sensor. Okay, so that's the basic idea. And when you go for the image, so this is the setup. For this, we are using Tinkercad software, not Tinkercad software, we are using the Tinkercad website. And when you talk here, see, this is servo motor 1, this is servo motor 1. There is some delay in this, I don't know why. Usually, I do not get this delay. I will explain you with the mouse. So this is servo motor 1, this is servo motor 2, and this is the ultrasonic sensor, this is the Arduino board. So the ultrasonic sensor, the common ultrasonic sensor that is commonly used, or that is basically used, is HCSR04. This is the ultrasonic sensor that we use. Okay, so we have to connect this, and we have to program it also. So let us go for the program very quickly, and then we will go for the circuit. So for the program, this is the program. Don't get confused by seeing this. So I have pasted this program here that I'm going to explain. Okay, so yeah, if you observe here, I will just increase the font, just a minute. Yeah, so see here, in order to make the Arduino board work with the servo motors, definitely we need a servo motor header file. This is nothing but just like the common stdio.h, standard input output header file that we use to make the input and output devices work. So just like that, this is the header file, and trigger pin, echo pin. I'm assigning it to the pin number 2 of Arduino board and pin number 3 of Arduino board respectively. Since I'm using two servo motors to control those, I need two servo motors which are nothing but the pin 6 and pin 7 of the Arduino board. So based on that, what I'm defining, constant integer servo pin 1, constant integer servo pin 2. This is completely user defined. This is completely user defined. Even these two are completely user defined. You can give names of your wish, but keep in mind what you are using here, that should be used throughout the program. Okay, that's the starting. And then you have servo motor 1 and servo motor 2. So this, you might ask me, what is servo pin 1, then what is servo motor 1? Okay, see, this servo pin is nothing but the definition of, or the or the assignment of pin number. That is a particular pin, that is the pin number 6. If you take in this case, the pin number 6 of Arduino board is connected to the trigger pin of the servo motor. Now this motor 1 is the actual parameter or the actual character that we are using. You cannot say it as a character, the actual string that we are using to identify the motor in the whole program, that is a servo motor. Okay, now this servo is the class where all the important files that are linked with the working of motor will be stored in this section of the program. Okay, so it's just like a header or a subheading in the header file servo.h. It's just like a subheading. Then when you go for the setup side, you have pin mode, trigger pin. So definitely the trigger pin is an output, that is the signal is going outside the Arduino board. That's why the trigger pin, that means pin number 2 is an output. The signal is going outside of Arduino boards. That's why it is defined as, or it is initialized as output pin. Whereas the echo pin receives the signal from the sensor, from the ultrasonic sensor into the Arduino boards. That's why it is defined as input. Now, we have not assigned any type, whether it is an input or output for servo pins, because we know definitely that servo pins are always uh, output pins, because you won't be accepting any signal from the servo motor. Instead, you will be giving signal to the servo motor from the Arduino board. That's the main reason we don't need to define it. But what we are doing is, we are linking the servo pins, that is the pin number 6 and pin number 7, with their respective motors. That's with the help of this command motor1 dot attach. Now motor1 dot attach servo pin 1. This means whenever you're giving command for the trigger pin of the servo motor, you are going to uh, find it with this name, and the function what you are going to do, it's the attach function. For example, see this next line. Okay, what I'm doing is, of course, by using servo pin 1, I'm sending the signal. There's no doubt. So this 180 is not the signal, it's the angle of rotation of the motor. What I'm going to do is, I am using the character motor 1 in order to find, or in order to locate the servo motor 1, SM1. And what I have to do, what the command that I have to do is, I have to write a voltage that is equivalent to 180 degrees. Okay, so I have to write the voltage. That means from the Arduino board, I have to send a digital signal that is equivalent, or that makes the servo motor to rotate by an angle of 180 degrees. So that's the main thing what I am doing here. I'm just linking the servo motors with the servo header files. This is the main writing pattern. That's the same thing what I'm doing here. I'm trying to attach the servo motor 2 with the servo header files. See here, you might have observed here the angle 180 degrees and 0 degrees. So initially, if you observe, this both the gates will be on a flat horizon, but when you see the directions, they both will be different. So you can call this as 0 degrees, and this one will be 180 degrees, or the reverse. This is 0 degrees and this one is 180 degrees. That is completely your wish, but both has to stay opposite, because one gate will open counterclockwise whereas the other will open clockwise. Okay, so that's why I have kept both the gates in the opposite directions. Now see, in the loop function, what I'm going to do is, first of all, I'm going to define two different variables, the distance variable and the duration variable. So the distance variable, as the name itself defines, is to calculate the distance of the object from ultrasonic sensor. and the duration is of course for the time. My idea is, if I am able to, definitely I know the speed. Okay, I definitely know the speed, and what I know the next is I know the distance. Okay, is it the distance? No, not the distance. I know the duration. I know the duration. Now, if you know basic physics, so distance is equals to speed multiplied by time. Based on this formula, what I'm going to do is, first of all, I'm going to find the duration. Then definitely I know the speed. That's the way I will be finding the distance by with the help of this formula, speed into time. So it is in the further side. We will discuss this. Okay. So you might ask me, why do we need this formula? Of course, we need to find the distance, but why only this? Because if you observe that ultrasonic sensors, yeah, you might get a doubt. How do we know the speed? We know the duration, definitely. I have defined a variable for that, but I have not defined a variable anywhere in the program for the speed. So you might ask me, how? How do we know the speed? And on what thing we are going to calculate the speed. So for that, you have to know the working of ultrasonic sensor. So the ultrasonic sensor mainly works on sound waves. Okay, it mainly works on the sound waves. And the sound waves, the speed of this sound waves is 340 meters per second. 340 meters per second. That way, we know the speed, and we know the duration of it. Okay, we only have to know the distance. Now, how does the ultrasonic sensor work? Yeah, we know. Let me just close this out. We know that the ultrasonic sensor works on sound waves. So if you have an ultrasonic sensor here, definitely this is going to transmit the sound waves. Okay, definitely it's going to transmit the sound waves. So this sound waves, the special property of this sound waves is, whenever they hit an obstacle, like say an obstacle here, these are going to be reflected back. Okay, just like the light waves. So when these are reflected back, some of that sound will come back to the ultrasonic sensor. Okay, so this is ultrasonic sensor, and this ultrasonic sensor, what it is going to do is, it is going to calculate the time that has taken by this sound wave to start from the sensor itself and come back to the same sensor. Okay, you might ask me, what happens if there is no obstacle? So the sound never comes back. That way, it can say that there is no obstacle. If it is receiving a return signal, if it is receiving a return sound wave, then that definitely means that you have some obstacle in front of it. Okay. Now, the next question is, how is it able to calculate the distance? We know that speed of the ultrasonic sensor sound waves is 340 meters per second. Now we know the duration, because here we are doing is, we will be taking note of the time when the signal will leave the ultrasonic sensor. Okay, so when the sound waves leaves the ultrasonic sensor, a timer that is built in will start to count. Then it will stop counting immediately after you receive an ultrasound, after you receive the returned sound wave. That's what we call as trigger and echo. So trigger is starting of the sound wave and the leaving of the sound wave from the ultrasonic sensor. That is trigger, and echo is the receiving of the triggered sound wave, or echo is the receiving of the reflected sound wave. So that's what we call echo. Now what I'm going to do is, I will start a timer in Arduino board. Okay, I will start the timer in Arduino board immediately after triggering the sound wave. Okay, immediately after triggering the sound wave, and I will keep a track of that timer until I receive an echo on the ultrasonic sensor. Immediately when I receive an echo on this ultrasonic sensor, that same will be sent to the Arduino board. So the Arduino board, immediately after receiving the echo signal, what it will do is, it will stop the timer, And what it is going to do is it will calculate, it will subtract the first time of the time when you send the trigger signal and the time when you receive the echo signal. It will calculate the difference and it will take, for example, so the sound waves took 10 seconds. Sorry, what I can say is when the when the trigger was started, the timer was at 0 seconds, and when I received the echo, the timer was at say 10 seconds. Now, what I'm going to do is this 10 seconds is the complete duration for the receiving of echo. Okay, so below 10 seconds, you won't be able to receive the echo. Now, if you observe at the figure, so let me just change the color. If you observe in this figure, this 10 seconds is for upstream travel of sound waves and the downstream travel of the sound wave. So forward direction and the reverse direction, including these two, how much time I need is 10 seconds. But my obstacle is not 10 seconds far. It is at half of the distance, because the time taken by the sound wave to travel in the forward direction is same the time taken by the sound wave to travel in the reverse direction. That's why what I'm going to do is I'm going to divide this time. I'm going to divide the total time by 2, because I need only the upstream or the downstream, the forward direction or the reverse direction. That means the trigger time duration or the echo time duration. I need only one. I don't need two. Okay, I need only one. So what I'm going to do is I'm going to make a note of time by using counters or timer, whatever it is. I'm going to take note of time, divide it by 2 and multiply it with the speed. So this will give me the required distance. So that's the working of ultrasonic sensor. So here there is another catch. See, the ultrasonic sensor always works, or it has or the sound waves has a speed of 340 meters per second. Observe here, it's meters per second. But our Arduino board or any kind of microcontroller, not this one, microcontroller will operate the timers only in microseconds. Okay, what we have here is seconds, but our microcontrollers, they have internal clocks, but those clocks will work only on microseconds. For that we have to convert these seconds into microseconds, and the ultrasonic sensor is able to calculate the objects or calculate a distance of only centimeters, because using ultrasonic sensor you will be calculating smaller distances, like a distance from your desktop table to the wall of the room. Okay, so that will be maximum in centimeters. It won't be in meters or in kilometers. So that will definitely will be in centimeters. So we have to convert the meters into centimeters also. For that, what I'm going to do is just watch the conversion here. So first of all, what I'm going to do is I'm going to write 340 meters per second. So that is 340 multiplied by meters per second. But I don't want in seconds. What I need is I want in microseconds divided by microsecond. If I write like this, the equation is going to be unbalanced. So that's why what I'm going to do in the numerator side is I'm going to write is as microsecond, so that this microsecond and this microsecond will get cancel out. Okay, and then what I'm going to do is I am I need the final value is in centimeters. So the same thing, centimeters divided by centimeters, so that the equation remains the same. So there is no cancellation. Okay. Now what I have to do is I am going to convert this seconds and this meters in terms of centimeters, so that they can I can cancel them out. So let us write this again. So 340 into meters by second multiplied by microsecond multiplied by microsecond multiplied by centimeter by centimeter. Okay, so this is the basic basic line that we have in the previous slide. So the next line is, what I'm going to do is I'm going to keep 340 as it is, but this meters will be converted into centimeters. So that will be 1,000 centimeters divided by. So if you take seconds into microseconds, that will be I think 10 lakhs. It should be 10 to the power of minus 6. Okay. So six zeros, 1, 2, 3, 4, 5, 6. Yeah, it's 100 lakhs. No, it's 10 lakhs. Yeah. So that ten lakhs microseconds multiplied by, I am going to write it. No, I have wrote it wrong. So, I'm going to write it in this way. So, microsecond divided by centimeter multiplied by centimeter by microsecond. I'm just changing the positions of this. So this microsecond will be cancelled out by this one, and this centimeter will be cancelled out by this centimeter. So what I have, 340 into 1000 divided by 10 lakh into centimeter by microsecond. So I got the units, but still I have something here. So this 1000 will be divided by this three zeros. Okay, so this will give me a total of 340 divided by 1000. Yeah, multiplied by centimeter by microseconds. So again, these will be calculated. No, I did somewhere, I did a mistake. Yeah, I did this wrong. So it's not 1000 centimeters, it's actually 100 centimeters. Okay, so 1 meter, 100 centimeters equals to 1 meter. So this would be 100, and based on that, let me just erase this. So based on that, so that's 100 centimeters, and so I will be having 100 here, and I will be having six zeros, 1, 2, 3, 4, 5, 6. So based on that, two zeros will be cancelled out here, and one from zero, 1 0 from here. So based on that, I have 34 by 1000. Yeah, now it's right. So finally what I will get is 0.034. Okay, multiplied by, yeah, of course, when you multiply that, that's centimeter per microsecond. Now, if you want to calculate the speed of sound, if you want to know the speed of sound in centimeters per microsecond, that's 0.034. So keep in mind this value. We are going to use it in the program. So where is the program? Here. Yeah, just let me just erase this all. Yeah, that's it. So I have defined a variable for calculating the time, and I have defined a variable for calculating the distance. What I'm going to do is, whenever I'm going to start the timer that is connected to the trigger pin, what I'm going to do is, before that, I don't know, I'm not responsible, or I don't want the trigger pin to be high. When I'm starting the timer, it must be at point 0. From that side onwards only, I will be able to calculate the exact time for the echo, for the receiving of echo from the starting duration. For that, initially, whatever the value of trigger pin is, I don't care. I'm just going to keep it as low. So initially, if it is 0, now it's going to stay 0. But if it is initially, if it was 1, then this will make a huge impact in my echo time calculation. For that, I need this trigger pin to be low. It should be in state 0. So it should be at the logic 0. When I'm starting the counter, then that trigger pin should go high, and it should go like this until you receive an echo. After you receiving an echo, the trigger pin will just drop like this, and it will go. Okay, so this is not clearly visible. I will show you there. In terms of graphs, okay, so the trigger, the echo, okay, and I don't need a separate timer for a separate graph for what we say, time duration, because within the trigger itself, you will be able to find the time. Okay, so when I'm starting a trigger, it will go high, and it will go like this, and echo will be turned off until you receive it. So when you receive it, the signal is going to be high, and when you receive an echo, definitely at that duration, the trigger pin will turn off like this. Okay, the graph will be like this. So this duration is nothing but your distance. This duration is used to calculate your distance. Okay, for that, my trigger has to be correctly 0 before sending the sound waves outside of the ultrasonic sensor. For that purpose, whatever the previous state is, that should become low. For that, what I'm going to do is, I'm going to keep that trigger pin, make that trigger pin low. Then after some delay, after 2 microseconds of delay, I'm making the trigger pin again high, that I can start the calculation of the time duration for receiving an echo. Then I'm waiting for 10 seconds, 10 microseconds, not 10 microseconds, and then I'm lowering of the, I'm turning off the trigger pin. Immediately after that, what I'm going to do is, I'm using a command called pulse in, which is going to calculate the complete time duration of the echo pin, which is going to monitor the time duration of the echo pin. So what it is going to do is, it's going to calculate for the time, or the time when the echo pin is high. Okay, for the duration the echo pin is high, it's going to read, the pulse in command is going to read the time duration for which the echo pin is high. After that, it will calculate the duration, and see here, you have 0.034 divided by 2. So that 0.034 is nothing but this calculation, this calculation 0.034 centimeter per microsecond. So why we have to convert this? Because I have told you, the microcontrollers are able to calculate only in terms of microseconds, and the ultrasonic sensor is able to calculate the distances of only centimeters, no decimeters, no meters also. So that's why we have to convert the meters per second in centimeters per microsecond. And while converting that, we get this value 0.034, which is nothing but the 340, which is converted in lower scale. Okay, so why we have to divide it by 2? We need only one one side direction, one side time only. We don't need the two-way times. Okay, so when you are receiving an echo, it's a two-way time. That's why we are going to convert the duration, we are going to convert the final duration divided by 2. Then I'm keeping a condition. If the distance is less than 30 centimeters, that means if the object is much closer than 30 centimeters to the ultrasonic sensor, the gates uh, come in open position. So open position in the sense the motor is going to open. Okay, think from the view of the motor. So open means the gates are going to get closed if you see in the real world. So basically the servo motor is at 0 degrees or it is at 180 degrees. Opening of these gates means rotating of servo motors. So rotating of servo motors, one will rotate to 0 to 90 degrees while the other will move from 180 to 90 degrees. So that's why in the comment line we have written gates open position. Okay. If the gates are yeah, if the train is at a distance of more than 30 centimeters from the ultrasonic sensor, that means there is no train. That means you won't receive any echo signal, and for that purpose, I'm going to keep. Okay, I might have written the condition a little bit wrong here. Gates close position. Motor dot 180 degrees. So yeah, it's a little bit different here. I will explain you. So distance less than 30 degrees means there is an object in front of you. There is an obstacle that is present at the ultrasonic sensor, and it is going to be at 90 degrees. Okay, so it's basically the placement of the gates and the placement of the arm that is attached to the servo motor. Uh, okay, we will see this while designing. So basic idea is if the train is near to the ultrasonic sensor, definitely it will be having a distance less than 30 centimeters. That's why our gates should close. So they should stop the traffic, and when the train has passed the crossing, definitely the ultrasonic sensor will not be able to receive the echo signal, and it should open the gates. So that's the basic idea, and about this logic we will see it when we are designing the circuit. Okay, so for designing the circuit I'm using Tinkercad. Yeah, this is a smart dustbin. Let me see what the condition was here. So code, yeah, this is correct. Less than 30 degrees, the lid should open. This is same as the smart dustbin also. Smart dustbin and the smart railway gate both are same. So let's go for designing. What I'm going to do is create circuit. So this is easy to log in. You just need your personal Google account or any other account, not Facebook and Instagram kind of accounts. You need a Google or some other accounts. So that will be asked when you are signing in. Okay. Now here, first of all, I need Arduino board. So that will be placed here. Then I need an ultrasonic sensor. Better to search here, and a servo motor. Servo motor. No, motor. What? Yeah, micro servo. So that's micro server, and I need another servo motor like this, and okay, I need an ultrasonic sensor. Oh, I missed the R. What? So yeah, ultrasonic distance. So this is different. I'm not going to use that. I'm going to use this kind. Now it's just the arrangement. I will be arranging this in this manner. I don't need this. Okay. I need this ultrasonic sensor. Yeah, I need. Okay, I will be dumping the code first here. So select the code. For that, I think I should not be having this all. Yeah, we will copy from here. Notepad, copied, and then this one. So just go to in the code and select text. Continue. Select all these. Select all these. I don't need this. This one, and that's it. If you even start the simulation, of course you won't be having any what we say syntax errors, but you won't be able to get the output. And yeah, one core component that I forgot here is the breadboard. So breadboard, any breadboard. So that's a long breadboard. We just need a small one like this. An ultrasonic sensor. Yeah. Now I'm going to open the code here and I'm going to observe, make the connections. So trigger pin of the ultrasonic sensor is connected to the pin number 2 of the Arduino board. And of course, yeah, the pin number 3 is not that one. The pin number 3 is connected to the echo pin, right? What I'm going to do is I'm just going to place it this way, right? Yeah. Now the pin number 6 and 7 are connected to the servo motors. It's not about that this pin has to be connected to this servo motor. It's your wish. You can connect whatever motor you want to the servo motor. You just need to place this. The only thing that you have to remember is when you are going to connect it, be careful. You need to connect those in signal pins. Okay. So the seventh one, what I'm going to do is, yeah, let me change the color of this. Black, orange. I will go with yellow. Yellow is it visible? Yeah, it's much easy to identify this. So that's one signal. It's better if I go for seventh one for the upper one. So seventh one, and another green. Oh, I have already used the green. No, be that yellow and pink for this one. Okay. Yeah, yeah, that's it. Those are the basic connections. Now I need a power supply that should be connected to the breadboard and uh, a ground. Okay. So for the power supply, what I'm going to do is I'm going to use a red wire and I'm going to use the 5 volts from the Arduino board into the breadboard like this. Okay. So definitely you can extend these wires. Just let me have a look. The ground is below that, so that's not a problem. We can keep it close to the breadboard like this. Now I need a black wire to connect the ground like this, which will sit in the ground connection of Arduino board. Okay, so this arrangement is completely aesthetic. It is up to you how you want to do the connections. So the different colors and all, that's completely based upon your taste. Now I need a ground pin, but I need some connections from here to here. For that, what I'm going to do is I'm just going to connect one pin from there to this pin. Okay, so this is the so this will do a continuous connection, and I need a red pin in order to make the power supply from there to here. So that what I'm going to do is I'm just going to connect the power supply to this pin, or else I can do it much better, right? So I will just delete this line. I can delete this line, even this also. And what I'm going to do is I'm going to move this to here in the last pin. Mm, Same for this one also. Okay, so I've connected in this way. So now what I can do is I can just take a power supply pin from here and it's just completely aesthetics. So let us do this connection and see. I am getting a little bit, a little small doubt here that this might short the ground and thing, but let us see. So this is just a trail. Uh, so I need to connect one power supply here, and there you go. It should be connected here, or else I will go one point this way, and no, that should not get here. This has to be connected here itself. So I'm planning to make these three connections in a sequential manner. That is pin number one, pin number two, pin number three. That way I'm thinking like this manner. So one goes there, this one goes there, and another power pin goes just right there. Okay, so I won't be needing these pins. Now I need three ground pins, ground wires. So one ground wire will just go from here to there. That's one ground pin. Let me connect it straight there. Okay, and another ground pin will go there. And the other ground pin goes there. So this is the complete setup. Okay, the basic idea is to keep the ground pins at one point so it's easily noticeable or easy to recognize, and to keep all the power pins or power lines at one side so that it is easy to identify them. Now, this is the servo motor, this is the servo motor, this is the ultrasonic sensor. Yeah, when you place this ultrasonic sensor, it will come at between. Yeah, this is much better. So see here, these are overlapped. Don't get confused here. Or else, what I'm going to do is, I can even reduce the distance, right? So I will reduce the distance. I will just reposition my wires. So the reason for that is when I start the simulation, you will come to know. I believe I have to just tell this line. Why this line is not getting deleted? So I don't know. Yeah. So the purpose of moving this ultrasonic sensor in the downside is when you run the simulation, of course, you should not be having any errors here. When you run the simulation, when you click on this, you must be able to see this object. So yeah, if you have observed this servo motor here, this is rotating, this is not rotating because I need the code here now. See, initially, the servo motor 1, which is connected to pin number 6, that means the pin number 6, this one, this pin number 6 servo motor has to rotate a angle of 180 degrees, and the servo motor 2 is idle at its initial position. So it is stopping at 0 degrees, and this is rotating an angle of 180 degrees. So that's the main purpose, that's the main thing, or that is the reason the second servo motor is rotating but not the first one. So I'm considering this as the first one and this as the second one. But when you go for, yeah, we go via the program, by the program. So this is servo 1 and this is servo motor 2. So servo motor 1 is rotating an angle of 180 degrees, I have mentioned it, and the second one is not rotating. So my idea here is this is the passage. Okay, so this is the passage. So this is the passage and the traffic is going this way, and the train track is like this, top to bottom, between the two servo motors, and there is a road in this way. Now when I bring this object close to 30 centimeters, so let us say it's, yeah, it's 33. Now when I bring it to 30 centimeters, see, so for 30 centimeters there is no difference, but when I bring it for 29.7 like that, so the gates are going to close. Okay, this will stop the traffic. This will stop the traffic so that the train can go. So basically one will be here, one gate will be here and the other will be here. So if you observe that, if you want to observe that, I can keep it like this and the other somewhere here. So in between this we are having some railway track. Now if you run this, yeah, the object is close to 30 centimeters. That's why it's stopping the traffic from this side and it's stopping the traffic from this side. When it's going to be cleared, so the gates are going to open itself. Okay, so the gates are going to open themselves. Now if you rotate this orientation, there will be a slight difference. You have to analyze that position. So instead of going on this code blindly, just try to analyze this project. So in that way you can tell that you have created a smart railway gate which can close itself and open itself based on the arrival of the train at the railway crossing. So that's it for this video. See you in another video.